Introduction to noise. Noise is unwanted sound. An intrusive sound that interferes with speech intelligibility or speech privacy is characterized as noise. Noise is a relative term and can range from low levels of intrusive sound in a quiet environment to very loud sounds in an already noisy environment. Noise is a type of sound, and it can be explained or defined as a type of sound that can be unpleasant, unwanted, annoying, or too loud for human ears. Noise pollution. The World Health Organization, WHO, defines noise above 65 decibels, decibel as noise pollution. To be precise, noise becomes harmful when it exceeds 75 decibels, decibel, and is painful above 120 decibels. Sources of noise. Noise pollution is largely a byproduct of industrialization, urbanization, and modern civilization. Noise pollution has two sources: industrial source, non-industrial source. The industrial source includes the noise from various industries and big machines working at a very high speed and high noise intensity. Non-industrial source of noise includes the noise created by transport/vehicular traffic, and the neighborhood noise generated by various noise pollutants can also be divided into categories, namely, natural and man-made. The most leading noise sources are road traffic noise, noise from aircraft, noise from railroads, construction noise, noise from industrial activity, noise in buildings, noise from consumer products, fireworks, etc. Road traffic noise. Noise from the motors and exhaust systems of large trucks are common sources of noise pollution. For instance, the interaction of tires with the roadway by trucks, buses, and private autos cause noise pollution. In cities, the main sources of traffic noise are the motors and exhaust systems of autos, smaller trucks, buses, and motorcycles. Read more on noise from vehicles here. Noise from aircraft. Aircraft are a major source of noise pollution, and the law prescribes noise limits on airports depending on the aircraft movement and the area where the aircraft is situated, i.e. industrial area or commercial area. Noise from railroads. The noise from locomotive engines, horns and whistles, and switching and shunting operations in rail yards are sources of noise pollution. Construction noise. The noise from the construction of highways, city streets, and buildings is a major contributor to the noise and air pollution in cities. For example, construction noise sources include air hammers, air compressors, bulldozers, loaders and dump trucks. Noise from industrial activity. Fans, motors, and compressors mounted on the outside of industrial buildings may disturb people living near noisy manufacturing plants. Above all, noise from machines and industries have a significant impact on industrial workers, among whom noise-induced hearing loss is unfortunately common. Noise in buildings. Internal building noise from plumbing, boilers, generators, air conditioners, and fans can be audible and annoying. Improperly insulated walls and ceilings can reveal the sound of amplified music, voices, footfalls, and noisy activities from neighbors. External noise from emergency vehicles, traffic, refuse collection, and other city noises can be a problem for noise from consumer products. Certain household equipment, for instance, vacuum cleaners and some kitchen appliances, are common sources of noise. Noisemakers, although their contribution to the daily noise levels is usually not very large. Fireworks. Indian festivals like Diwali, marriages, etc. use fireworks during celebrations. However, bursting firecrackers is a health hazard since it is responsible for both air pollution and noise pollution. The noise created is hazardous, can lead sometimes to non-recoverable hearing loss. Types of noise. Depending on the frequency range, there are 4 different types of noises, as listed below: continuous noise, intermittent noise, impulsive noise, low-frequency noise. Continuous noise. Noise that is produced continuously, for example, by machinery that keeps running without interruption. This could come from factory equipment, engine noise, or heating and ventilation systems. The specimens used or any sample of continuous noise are all mainly caused due to the machines that run continuously with no breaks in between. Just like while riding a car we hear the sound of functioning parts, especially such as the sound of an engine. The main source of continuous noise could be the production factories. We have seen that in factories large machinery produce continuous noise such that barely we can hear anything else. Intermittent noise. The intermittent noises are such sound frequencies that are not produced continuously. At the same time, the intermittent noises are produced continuously but with particular intermediate breaks. The best day-to-day illustration and example of the intermittent noises are the drilling machines, which we would have seen during the destruction or construction of any kind of building. The drilling machines are used to drill the ground and these machines reproduce unbearable sound. Another best and relative example of intermittent noise is drilling machines employed by a carpenter or the dentist. Also noise caused by a train passing by, factory equipment that operates in cycles, or aircraft flying above your house. Impulsive noise. Impulsive noise is most commonly associated with the construction and demolition industry. These sudden bursts of noise can startle you by their fast and surprising nature. Impulsive noises are commonly created by explosions or constructive, low-frequency noise. The low-frequency noises are generally produced from the items available in our surroundings in our everyday life. The low-frequency noise is one of the complicated types of noise to scale back, and even if it is measured in a silent room still it would register sound levels around only 30 to 40 decibels. The low-frequency noise can be noticed in an office setting. This noise might have been produced from heating or ventilation. In domestic cases, it will arise from the ticking on a timepiece or wall clock. Usually, we cannot even recognize these sorts of noises unless we direct our attention towards them. Types of noise in communication. Physical noise, psychological noise, technical noise, social noise. Physical noise. Physical noise refers to the interference caused by environmental factors such as ringing of a doorbell. Technical noise. Technical noise involves the failure of the medium of communication like an unclear phone line or handwriting that is hard to decipher. Social noise. Social noise is a result of the social or cultural difference between the members involved in the communication process. Psychological noise. Psychological noise depends upon the mood of the receiver at the time of receiving of the message. Effects of noise in human health. Unwanted sounds can have a range of mental health effects. The brain is always monitoring sounds for signs of danger, even during sleep. As a result, frequent or loud noise can trigger anxiety or stress. With continued exposure to noise pollution, a person's sensitivity to stress increases. Trusted source. People living with noise pollution may feel irritable, on edge, frustrated, or angry. If a person feels they cannot control the amount of noise in their environment, its impact on their mental health intensifies. Noise pollution can be hazardous to human health in the following ways. Hypertension, hearing loss, sleeping disorders, cardiovascular issues. Noise curve. Noise curves are a common way to characterize background noise in unoccupied buildings and spaces. Their purpose is to produce a single-value representation of a complete sound spectrum. The noise rating, NR, curves are developed by the International Organization for Standardization, ISO, to determine the acceptable indoor environment for hearing preservation, speech communication and annoyance. The noise rating graphs for different sound pressure levels are plotted at acceptable sound pressure levels at different frequencies. Acceptable sound pressure levels vary with the room and the use of it. Different curves are obtained for each type of use. Each curve is obtained by a NR number. NR and NC values are a way of describing, as a single figure, a measured noise level that takes into account the frequency content of the noise. They are often used in the measurement of noise from mechanical sources such as air conditioning systems in environments such as hotels, cinemas and schools. The Optimus sound level meters and the Noise Tools software can provide both NR and NC values. NR or noise rating curves. The noise rating or NR curves were developed by the International Organization for Standardization, ISO, to determine the acceptable indoor environment for hearing preservation, speech communication and annoyance. North Carolina or Noise Criterion Curves. Noise criterion or NC curves were established in the US for rating indoor noise such as noise from air conditioning equipment, etc. The method consists of a set of criteria curves extending from 63 to 8000 Hz. The criteria curves define the limits of octave band spectra that must not be exceeded. Noise criterion curve. Some examples of these include the following.